In today's lesson, we're going to wrap up with the final two sets of formulas for our trig identities unit. In the first set you can see here on the screen, we've got the sum to product identities. So take a moment, jot them in your notes on page 8 if you'd like. If not, they're on that right-hand column on your formula sheet. But these last two sets, what you'll notice is they're very crazy looking. So, you don't want to have to use these unless they're going to be a benefit to you. You also notice, like if you see in a proof or a verify problem, if you have something like this, then that might be a way for you to work back to get to something more simplistic like this. We're going to see a couple examples with actual angle values. And the thing to keep in mind is that normally, like if we have sine of an angle plus sine of another angle, like our first one, the angles that they're putting in there, we can't find on the unit circle directly. So by allowing ourselves to do u plus v divided by 2, the angle then that we would be working with at that point would be something on the unit circle. So if you didn't already, pause the video, take a note on these four identities, and then we're going to take a look at the opposite, the product to sum. All right, and again on page 8, if you would like to, you can add in the product to sum identities. These look a little bit less intense because there's not the crazy fraction in the middle, but there's still the 1/2 out in front. They're basically derived from one another. So jot those in, and then what we're going to do today is just take a look at some examples of how we can use this to find exact values, and also how we're going to work these into our verify problems. So if you need to, pause the video. If not, I'm going to go ahead and get started. All right, so our first example says find the exact value. So again, this is how you know that you're not going to be plugging this in your calculator, because you know that your quiz tomorrow and your test on Monday are not, there's no calculator allowed. But notice here we are asked to find the cosine of 195 and 105 degrees. And if we take a look, neither of those angle measurements are on our unit circles. So what do? Well, if we scan, and obviously we're kind of geared towards using these because we're just learning them, but if we scan the formula sheet in the sum to product, because we have a sum of two cosines, we see one that is cosine of u plus cosine of v. So I'm just going to rewrite the formula to start out. So cosine of u plus cosine of v equals, and then it's 2 cosine of u plus v divided by 2 times cosine of the same quantity but subtracted. And what should happen here is that when we replace u and v with the numbers given in the problem, we should be able to actually find values that are on the unit circle. So let's do that. So 2 times cosine of 195, again, we're working in degrees, plus 105 times cosine of 195 minus 105. And if we simplify each of those fractions, so if we take 105 plus 195 divided by 2, that gets us cosine of 150 degrees. And then the other one would be 90 divided by 2, or 45 degrees. And both of those angles, of course, are on the unit circles. So what's something that looked pretty intense, or something that we couldn't potentially solve at the beginning, now we can, and we just have to find two trig values. So 2 times cosine at 150 would be negative root 3 over 2. And cosine at 45, that's that root 2 over 2. Using our algebra skills, again, make note here, this first 2 is a 2 over 1, so we do have fractions everywhere. I also know that there's only one negative, so we'll just bring that out in front. And then you can either just multiply everything across and then simplify, or you could, like I could cancel out these two 2's, but I can't cancel that last one, right, because we're only, we only have 1 2 in the top. But either way, you should end up with negative root 6 over 2. All right, and as we continue through these examples, I would recommend, maybe not for the first couple if you don't want to, but I would recommend that you pause the video, try to work on your own, and then play the video to see if I do it the same way. Also note that as I continue through these, there is a good chance that there's multiple ways to go through, at least some of the ones towards the end. So do try these and then use the video as a help. Don't obviously bank on the fact that I'm going to be able to work through every problem for you, because you know for your quiz and for your test, I will not be able to do that. So for example 2 here, we have a sum of two signs on the top, a sum of two cosines on the bottom, and we're going to a double angle. So lots going on with this one. If I go to what is more familiar, right, we've done double angle prior to now, but if you look on your formula sheet, tangent of a double angle only goes to a tangent fraction, and it doesn't look like what we see in front of us. So I'm going to start on this side, and I'm going to use that sum to product formula twice. Once for the numerator, once for the denominator. So when I rewrite the top, we've got sine plus sine, so that rewrites as 2 sine of, and then it would be the addition of the two angles divided by 2, and then cosine of the subtraction, so t minus 3t all over 2. And then we'll do the same thing for the bottom, but we're going to write the cosine formula this time. So 2 cosine of the addition of the two angles times cosine of the subtraction. Now, you might be thinking that's a mess, and what did we just do, because that still doesn't look like tangent. You are correct, it doesn't, but let's look a little bit closer. Everything here, except for what's inside of the parentheses, is being multiplied. So anything that is the same top and bottom can immediately cancel out. So for example, the 2's, they're gone. 2 divided by 2 is 1. If we look down the line, the next terms are sine and cosine here, so they can't cancel. But down here we have cosine, cosine, t minus 3t over t minus 3t. That is identical, so those terms cancel out. And now when I go to rewrite this, we have sine, and I'm going to perform the operation inside the parentheses. So t plus 3t would be 4t. 4t divided by 2 would be 2t. Perfect. And cosine would also be for 2t. Our goal was to get to tangent. Well, tangent is sine over cosine, so we're there. This would be tangent of 2t. And we'll write our verify statement. All right, so obviously on this one, if you look at the values, the angle values inside of the sine and the cosine, those are numbers that are on the unit circle. What they want you to do is, especially because we're just learning the sum to product and product to sum, they want you to play around a little bit with those formulas and get more acclimated to them. So obviously there would be a potential faster way for this, but we are going to work the formulas a little bit just so we can see what they look like. So note here, obviously the 4 out in front is just a multiplier. It doesn't have anything to do with the product to sum formulas, but I have a product of sine times cosine, so I'm going to rewrite that in the product to sum formula for that. So we'll bring the 4 out in front, and then our product to sum formula for sine of u cosine of v, so this would be u, this would be v, if I just go to rewrite, would be 1/2, and then it would be sine of pi over 3 plus 5 pi over 6. And then we're going to add to that sine of the subtraction of those two angles. And all of this inside here is being multiplied by the 1/2, and then close out the last set of parentheses because we still have that 4 out in front. So now from here, let's clean this up a little bit. So we have two angles inside of each sine function. Let's actually perform the operation there. So if we take pi over 3 plus 5 pi over 6, well, they're not like denominators, so pi over 3 would be 2 pi over 6. So this would be 7 pi over 6 if we add those together. And when we subtract, so 2 minus 5 would be negative 3 pi over 6, but obviously we can write that as negative pi over 2. Okay, so that was in the innermost set of parentheses, and we still have that 1/2 hanging out in front, and all times that would be the 4, which you can do something there if you already see what to do. You actually can do that here. Keeping the 4 out in front and then the 1/2 next, we can apply the trig values for sine of 7 pi over 6 and sine of negative 1/2, or negative pi over 2. So sine at 7 pi over 6 would be negative 1/2, and then we're going to add to that sine at negative pi over 2, but that would actually be negative 1. We just got to make sure we're following our algebra rules here correctly. So I said this earlier, what you could have done right out the gate, because again, these two are being multiplied and there wasn't an addition or subtraction that the 1/2 was affected by. I'm going to perform that multiplication here. So let's change the color. We can do this and make that a 2. And then inside the parentheses, -1/2 plus -1 would be -3/2. And then our 2's would cancel. So this ends up being just a -3, which again, I'm not saying that this is the way that I would do this problem every single time. If you were asked to do this on your test, unless they specifically say use product of sum, I would just go find sine of pi over 3 and cosine of 5 pi over 6. But just to show that these obviously do work, if we were to do it, the shortcut way, it should still end up being -3. All right, so again, if you haven't been, I would suggest maybe at this point, start to pause the video and allow yourself to think about the problem before I go through it. I know that it's super easy to watch me do the problems, but that's not going to necessarily help you and your brain start to process what it needs to do to get from one side to the other. So on this one, again, now we're starting to get into just some general practice. So not every single one of the problems that we're going to do for this half are going to be product to sum and sum to product related. When I look at this question, the first thing I notice is we have squared signs, we have double angles, and a quadruple angle, actually, for alpha. Remember, if you don't like alpha, you could call it x if you want to. I'm going to stick with alpha, I believe, but you don't have to do that. And if I scan my formula sheet, so again, we talked about the fact that this is a menu. Don't get hung up on the fact. So maybe right out the gate, you're thinking, oh gosh, there's squared signs, so I might want to use Pythagorean identity. Or maybe you're drawn to the double angles and you want to write a double angle formula. I would just pause for a moment and let your brain kind of ponder, what all do you see? What entrees are available to you? Where could you turn? If you try something and it doesn't work, what else could you potentially use? Now, whether or not this jumps out at you right away or not, I notice that we have cosine squared minus sine squared, and that is a double angle formula. So let me actually write that off to the side. So cosine of 2u equals cosine squared of u minus sine squared of u. Okay. Now, if I think about this for a moment, 2 alpha times 2 is 4 alpha. So one is the double angle or half angle, however you want to think about it, of the other. So this double angle formula that I have off to the right here seems pretty logical. The structure is there. We've got cosine minus sine squared, right? And we have 2 alpha and 4 alpha. So in this case, one way that you could show what you're up to is if I consider this to be u, as it's written over in the formula on the right. Well, then this side would be 2u, right? Because 2 times 2 alpha would be 4 alpha. So what I'm going to do is when I rewrite this, I'm going to rewrite the entire left-hand side as cosine of 2u, or cosine of 2 times 2 alpha, and that is cosine of 4 alpha. So again, sometimes we can use a direct replacement, even though it looks kind of crazy because that the angle that we were working with was already a double angle, but that'll work here in this particular case. All right, again, I really think that on this one, I would suggest that you kind of pause and think for a little bit about what all your options are. This one has a variety of things that you can do. I'm going to show you one option, but it's not necessarily the only way. So go ahead and pause and try this one and then come back when you're ready. All right, so lots of opportunity here. When I look at this at first glance, I notice we've got cosine over cosine. We have a sine squared going on in the problem. If I look for, either side to be on the formula sheet, I don't see either option directly, right? There's not like a 1 minus 4 sine squared somewhere, or what really jumps out at me is this cosine of 3 beta, right? I don't have that anywhere. And that's actually the side I'm going to start on because I want to get rid of that. I don't like the 3 beta. It's tempting, maybe, hopefully not, to maybe like divide the betas or divide the cosines. You can't do that here. We don't have a division rule in this case of like cosine divided by cosine or something like that. So we do have to actually use something that we did in our warm-up with the cosine of 3x, I believe it was. We're going to split that up and write a sum and difference formula first. So I'm going to start on the left, and I'm going to begin by rewriting cosine of 3 beta as cosine of 2 beta plus beta. So I'm going to use my sum and difference formula. So when I rewrite the numerator there, that would be cosine of 2 beta plus, or not plus yet, times cosine of beta. Actually, it's going to be minus because cosine uses the opposite sign, and then we do sine of the two angles. So 2 beta sine of beta. And again, if you don't like beta, you're more than welcome to write beta equals x or whatever you'd prefer to use and go from there. Now, that really just made a mess, right? And when we talked about this before, now you have cosine of a double angle. So there's 3 options for this. You have sine of a double angle. So again, I'm going to start by rewriting that so we can see what we're working with. And I also have this fraction involved. So eventually we can't do anything with it yet because the second term is all sine related, so we can't cancel it out or anything. But what I'm going to do is rewrite both of my double angles and go from there. So I'm going to rewrite the second one first. So sine of 2 beta would be 2 sine beta cosine beta, and then the sine beta that was already there. And then we've got the cosine beta, and now we got to choose which of the double angle formulas we want to use for the cosine. Again, thinking about where I want to get to, I want everything to be in terms of sine. I already have a cosine beta in this term. I'm going to distribute it into whatever I decide, whatever option I decide to put in here. Thinking also kind of fast forward, cosine beta is going to be here. So I still didn't pick something for the double angle yet, but we saw this yesterday in our warm-up. This is going to become sine squared beta cosine beta. And as long as I have a cosine beta in the first term, the denominator will be able to cancel out. So which option to use? Remember, I'm going to put a star here because if we choose one that just doesn't seem logical, then I can always come back, right? But if I choose one and it works, then clearly we're good to go. I'm going to go with, because we do have cosines and sines floating around, I'm going to try the cosine squared minus sine squared, and this is beta. Maybe that was your pick, maybe it wasn't, doesn't matter. We're going to try this one and see what happens. So when I distribute, so now I'm going to have to distribute this in, we'll have cosine cubed of beta minus, and we can just multiply these together. And now that I take a look, so again, this is working out the same as the problem that we did for the warm-up yesterday because we use the same strategy. We just have that cosine beta in the denominator. So we will have cosine cubed of beta minus 3 sine squared of beta cosine of beta. So what I can do now is, because both terms in the numerator have a cosine of beta, I'm going to cross this one out and make that a squared, and I can cross this out as well. So I took one away. I basically took out a GCF of cosine beta. From here, let's rewrite this. We've got cosine squared of beta minus 3 sine squared of beta. That's what we're left with at this point. I'm close. I've got negative 3 sine squared of beta. I need negative 4 if I look back up at the top. I also somehow have to get a 1. Now that I just have cosine squared beta and I don't want it, I want that to be in terms of sine, I'm going to bring in my good old Pythagorean identity. So I'm going to rewrite this, I'm going to come up here, as 1 minus sine squared beta, and there it is, minus 3 sine squared beta, so I have negative 1 plus negative 3. There's what I needed. Now again, is this the only way to have solved this problem? Probably not. because again, where we had this star over here on the left, we could have put in either of the other two options. I'm not saying that this is the fastest way to go about it, but it would be a potential way to go to get to that final answer. So let's take a look at a couple more. All right, again, pause the video and try this next example. You should find that this one is similar to one that we've already done. First thing I notice is that we've got sine of x plus sine of y across the top, and then on the bottom we have cosine x minus cosine y, and those are sums or differences that we can rewrite as a product. I could start over on the cotangent side, but we don't really have a formula for x minus y over 2 because it's not like our, it's not completely a half angle formula. So I am going to start on the left, and I'm going to rewrite again from sum to product. So the top would be rewritten as 2 sine of the quantity x plus y all over 2 times cosine of x minus y all over 2. On the bottom, cosine of a difference is written as negative 2, and then it's sine of x plus y over 2, and sine of u, or x rather, it's u on the formula sheet. Okay, so again, take a moment and just look at what you notice now that you have all of the pieces set up. Again, everything is multiplication. The only add or subtract is within the parentheses, which is just building to find the overall angle measurement. So we don't have to worry about any type of adding or subtracting. Since it is all multiplication, I should be able to cancel out terms that are the same top and bottom. So I notice here that I have two 2's, one on the top, one on the bottom. Note, though, that I do have a negative, so that did not cancel. If we look at, we have sine over sine. We have to be careful here which ones we can get rid of. I see x plus y over 2, so these two signs can cancel. So as of right now, I have negative, and then if I look, the last two trig functions both have the same angle measure inside. It's a mess because it's x minus y all over 2, but whatever those values are, it's going to reduce to like the same degree or radian measure. So because it's cosine over sine, well, that's cotangent, and I would just write x minus y all over 2, and there we have it. We're verified. All right, again, pause the video and try the example, and then come back to see how I did it. All right, so first and foremost, there's a couple different pathways here on how you could potentially work through this. I noticed that we've got cosine of a sum plus cosine of a difference. So I'm actually going to go back to sum and difference formulas here. I also noticed that we have cosine plus cosine, so you could work with the sum to product formulas and probably verify this in a different path. But if I rewrite our sum formula for the first one, we would have cosine of the first angle times cosine of the second angle. And because it's plus in the formula sheet, it's the opposite. And then we would do the sines of the first angle times sine of the second angle. Then the big plus is from this guy in the middle. And then we're going to rewrite the same formula basically, but instead of plus in between, we're going to have minus. So that should mean good things for what we need to do next. So then we need plus, and then it would be sine of pi over 3 sine of x. And at this point, I want to note a couple things. So first of all, my goal is to get rid of all of the signs because the final answer is just cosine x. And also I notice, and when I said it, I was thinking this ahead of time, notice that we've got the negative sine pi over 3 sine x term, and then down here we have the positive sine pi over 3 sine x term. So those, no matter what the actual value is, going to be a negative and then a positive, they're going to cancel each other out. So that means I am left with just cosine pi over 3 times cosine x, and actually there's two of those. So I'm going to rewrite it like this. Now, obviously cosine of pi over 3 has a value because that is a unit circle angle. So at pi over 3, the x value is 1/2. And look at that. 2 times 1/2 times cosine x, well, 2 times 1/2 is really 1, so we're verified. And again, that's not the only way you could have gone through that. You could have built the sum to product formula, and then you would have actually had to add, let me write it off to the side here, I'll write it in a different color, but like the u plus v over 2 deal would have been, u would have been like pi over 3 plus x, and then v would have been pi over 3 minus x, and all of that would have been over 2. So if you use product to sum, you would have ended up at that placement after you simplified. I just chose to use sum and difference. But again, that's the beauty and the curse of these. There's multiple ways to go about them. All right, let's try another. All right, so taking a look here, I feel like we've seen this one before, so give it a try and then come back to the video to double check. Remember that there are multiple ways to go about this. So I'm going to start on the left. You could most certainly start on the right. But the big thing here is make sure in your work that the squared did not just get distributed. This needs to be a Euler box problem. So when we do that, we're going to get sine squared of x plus, I'm going to write out both terms, but you may have already written this as a combined term since there are two of them. But double check your work, your FOIL or your box with this and make sure you have all of that. But what you should notice, first of all, is this middle term is the same, so we can write that as a 2 sine x cosine x. And the other part is that we have a cosine squared x plus a sine squared x, and hey, that's a 1, right? Now, if you didn't recognize 2x or 2 sine x cosine x right away, maybe looking back at the right-hand side will jog your memory what that is, but that is our double angle formula. So we are actually verified already. And you could obviously have worked down the right-hand side and kind of worked backwards. The part that maybe you would have gotten stuck on is like, if I was trying to go from this step up, right, it would be kind of odd to replace the 1 with sine squared x plus cosine squared x, but that's probably what you would have had to have done. So then you could see that you would factor that to the quantity sine x plus cosine x squared. But that would have been another option. All right. All right. Go ahead again, pause the video, give this one a whirl. And again, what you should notice is really you've got fourth powers on the left in the format of a dots problem. So I'm going to start this one using factoring, not the only way to go about it. Whereas we have a cosine of a double angle on the right. So this one you could certainly start with the double angle formula over there. I'll show you why, though. I'm going to work from the left-hand side down. So when I do dots to this, I'm going to get cosine squared of x plus sine squared of x. Wonder what that is. And then I'm going to get cosine squared of x minus sine squared of x, right? And in this case, this whole quantity goes to 1, right? Because that's Pythagorean identity. So since I'm multiplying it by the other quantity, I don't even need it. And if I look at cosine squared x minus sine squared x, again, maybe looking over to the right will help you here, but that is one of the 3 versions of the cosine double angle formula. So this one is literally kind of 2 steps here because we are verified. All right, and I believe we have one more. So we have got tangent of a half angle equals cosine of u minus cosecant of u minus cotangent of u. So again, you might choose to start on either side. I think I'm going to start on the right-hand side. I've been doing a lot on the left. I know that tangent of a half angle has the 3 formulas. Obviously, I want to avoid the square root as much as possible. But if I had an inkling of which of the 2 other tangent of a half angle formulas I would want to use, then I would maybe start on the left, but I'm hoping that I can kind of work the right-hand side down and find the matching half angle formula and just work backwards. Totally up to you, though. You could do whichever one you want. So if I rewrite the right-hand side, that would be 1 over sine u minus cotangent is cosine over sine. So beautiful thing here, I have a like denominator, so I can combine the fractions, and actually that should do it, because if I look at my formula sheet, it's x instead of u, but 1 minus cosine x over sine x is the half angle formula, the third option on your formula sheet for tangent of the half angle. So just make sure here, remember we talked about this before, if you're not a fan of the u, like if on this problem you were like, let's do this instead, totally legal, just make sure you're making the key if you want to write in terms of x instead of u. All right, so continue to practice. There should be some other stuff in Canvas that's posted at this point for you to look at. We will have a quiz tomorrow, and you can also reach out to me if you have any questions. Good luck.